This is part 2 of our TID Water and Power Podcast episode on regulating reservoirs. If you haven't yet, we recommend tuning in to part 1, which is available in our podcast feed right now, and then coming back to this episode. Now, let's get into the show. We're now joined by Senior Civil Engineer Matt Hazen to discuss the engineering and design of the regulating reservoirs. Matt, thanks for joining us.
Thanks, Constance. I'm happy to be here.
So this is your first time with the podcast, and we're excited to have you. Would you start by telling us a little bit about your background with the district?
Yeah, I'm a senior civil engineer with the district. I've been working here for about 15 years. I started here almost directly from college after a brief stint in the private sector in Paso Robles.
Very good. And when did you become a senior civil engineer?
I became a senior civil engineer about 3 years ago.
Okay, very good. And have you enjoyed the projects you've worked on so far?
I have. I've very much enjoyed the projects. It's been an exciting last 4 or 5 years for the district. A lot of things that we've been dreaming about or planning for coming to fruition.
Great. All right. Well, let's not waste any time and jump into a couple of those projects. Because you served as project manager for both the Lateral 8 and the Series Main regulating reservoir. Is that right?
I did.
Okay, very good. And so that included then designing the reservoirs. What elements do you have to consider when you're designing a project of that scale?
You know, it's a very complex design process. The first thing that we have to do is select a site, which is a task in and unto itself. We have to find a location that meets the water and hydraulic needs of our canal, one that touches as many different canals and as much acreage as possible, and one that will be obviously available for sale. We don't want to eminent domain anybody. And then also we need to take into consideration the surrounding ground, the usage of the surrounding ground, whether it's orchards or row crops or industrial or agricultural.
Mm-hmm. And how those surrounding areas might be affected by the reservoir.
Correct. And the construction of the reservoir.
Ah, true. And then, so once you have kind of identified a location and you think you're moving forward, anyone else that you consult in that process when putting the design together?
So yeah, once we have a site selected, we then have to do some investigation of that site, some thorough investigation of the subsurface soils, some investigation of any environmental impacts that might be occurring because of our construction or change of the usage of that property. And then we have to look into what permits we might need to acquire for that parcel. Once we've kind of identified all of the design constraints, if you will, that's when we really move on into the meat of design, actually establishing how deep we're going to dig the basin, how much earth we're going to generate, whether or not it needs to be lined, which in the case of our 2 reservoirs both needed to be lined in order to prevent infiltration and impacts to the surrounding grounds, and then how it's going to interact with our canal system, whether it's going to be gravity in, gravity out, pump in, pump out, those sorts of considerations. And then we begin, drawing up sort of concept design. We route that for comments amongst all of the different stakeholders that are going to be impacted by this facility, make revisions to that, and then get into the nitty-gritty details of exactly, how much concrete are we going to need, where it's going to be placed, how much rebar is needed in the walls, those sorts of nitty-gritty engineering details.
Got it. Okay. So considering all these different elements that have to be taken into consideration, tell us a little bit about what distinguishes the Lateral 8 regulating reservoir from the Series Main regulating reservoir.
So actually, the 2 reservoirs have a lot more in common than they have different. Both are concrete-lined, earthen dammed reservoirs. Both operate in roughly the same in the same fashion. But the Series Main is, however, much bigger, almost twice as big as the Lateral 8 regulating reservoir. It's also situated on a higher capacity canal than the Lateral 8 reservoir is. The Lateral 8 was a pilot project, sort of our first attempt at using a regulating reservoir. And it was so successful that we moved on to this much more beneficial location, a much more central location and impactful location of the Series Main. just to give you an example, the Series Main Canal has a capacity of 500 CFS, whereas Lateral 8 has a capacity of only 100 CFS. And the Series Main touches a lot more canals than the Lateral 8 does.
Okay. So you mentioned that the Lateral 8 regulating reservoir started as a pilot project. Can you go into a little more detail on that and how kind of what we saw in that pilot project that encouraged the district to expand that project?
Absolutely. So the Lateral 8 pilot just began with a much smaller reservoir than is actually there now. We bought the entire property, but we started with a pre-existing wastewater treatment pond that Hillmar County Water District had at the site. And we wanted to test having a reservoir there with a total channel control system downstream, which is a canal automation, which would allow the canal to pass water from the lower end back up to a reservoir. It was a good site because there were two canals that were immediately adjacent to each other and very nearby, both Lateral 7 and Lateral 8. And reservoir had been considered there for a number of years just to provide a resource to the ditch tenders on the bottom end as they were having difficulties keeping up with demands on the lower end of the system with all the fluctuations that came down. The reservoir element was so successful, they utilized it so much that when we asked them what their feedback, with the operators out there, what their feedback was, they just asked for more storage space. That's all they really wanted. They loved the facility. They just needed more storage space, more flexibility. And so then we expanded the very next year out to the full-size facility with 130 acre-feet capacity and added 2 more pumps just to give them more options for accessing water when they needed it and capturing spill water that was coming down the Highline Canal.
Oh, that's great. We can only hope that all of our pilot projects are so successful.
Yeah, absolutely. And it really made the operators on the other canals so jealous. They all started asking us for regulating reservoirs.
I bet. A hot commodity. So, Matt, you mentioned that the entirety of the Lateral 8 project, the full build out, is lined. Was the pilot project lined as well?
No, the pilot reservoir, which was essentially constructed out of the Hillmar County treatment ponds, was not originally lined. And we did that for a few reasons. One of the reasons was that we knew that we would likely be expanding that facility into the full size. That's why we bought the full property if the pilot was successful. So we didn't want to be putting in concrete liner, paying, the cost of concrete liner or other kinds of liner when we knew we would need to demolish at least half of it, building out that facility. The second reason was that we did some percolation calculations on the Hillmar County treatment ponds, and they had some numbers already for us for those ponds. And because they've been so heavily utilized over the past, the perk rate through those ponds was not quite as high. Water didn't move down quite as fast as it did on the surrounding ground. So we felt that we were not going, that paired with the size of the reservoir, we weren't going to lose a significant amount of water.
And so instead of doing like a concrete liner or some other more permanent liner, you guys used something called riprap. Is that right?
We riprapped the sides of the reservoir, and that was more to just prevent erosion from the wave action inside of the pond and scour around the pump station. So yeah, we did riprap the sides, and we've been able to reuse that riprap. We had to remove it when we lined the full facility, but we've been able to reuse that riprap to good effect elsewhere in the district. We did not just dispose of it.
All right. So then with regard to the Series Main regulating reservoir, you mentioned that it's a bigger reservoir. It's on a higher capacity canal. And you mentioned that it's more centrally located. Can you explain that for us a little bit?
So the district is very large and encompasses 150,000 acres of land, and our system spans the entire range of that acreage. The Series Main is located almost midpoint between the 3 rivers that the district canals spill into: the Tuolumne, the San Joaquin, and the Merced rivers. It's located on one of our most important main canals, which has the upper laterals that all spill into it from the east side of the district, and then has all of the lower lateral, or a large portion of the lower lateral canals that are fed by it. So all the way from lateral 1 to lower lateral 4 and 4.5. So the series main is situated right about midpoint between those lower laterals. And because we took the step of also installing a TCC system below it, it actually has access to pretty much assist all of those lower laterals.
Very cool. Great. And we're definitely going to come back to this TCC system you mentioned. I want to talk a little bit more about that. But first, can you tell us about what you learned in now having built first having built lateral 8 and now having built the series main regulating reservoir? What did you learn from one project that you were able to carry over to the next?
Yeah, so learned a great deal from lateral 8. One of the issues that we ran into that we weren't anticipating was the inlet to the sump area at lateral 8 was essentially a box weir. It was flush with the floor, but essentially acted like a weir once the water levels in the reservoir dropped to 6 inches or less. And what that did was, with the heavy pump capacity, the pumps at lateral 8 pump up to 20 CFS each. With that heavy amount of draw, the inlet acted like a restriction. And caused those pumps to essentially cycle on and off when the reservoir was extremely low. A situation that doesn't happen very frequently, mostly when we're draining the facility for maintenance, but still created a headache that for our maintenance people. So when we were designing the series main, we made sure that inlet was much more broad, had a much larger area to draw from, so that wouldn't be an issue. We also increased the size of the sump so that the pumps would be effective at dewatering all the way down to the bottom of that new facility. The other thing that we had an issue with on lateral 8 was, despite meeting all of the industry standards for pumping, we had some issues with surging on the outlets of those pipelines into lateral 8. Something that was very easily rectified by essentially putting a deflector plate over the top of the outlet facility and, deflecting those surges into the canal. Didn't impede pump function at all, but did create some nuisance water on the bank. So when we did do the design for the series main reservoir, we increased the size of the discharge pipes and their orientation going into the series main canal to help avoid that surging issue. So we reduced the velocity pretty heavily, and like I said, changed the discharge location.
Okay, great. So some good lessons learned.
Absolutely, yeah, absolutely, and definitely going to continue to learn from all of these new facilities, because each facility has its own little differences.
Absolutely, sure. So you've mentioned a little bit now about, the pump in, the pump out, the changes that were made from one project to the next regarding the sump and the, some of the mechanical workings of it. Let's take a step back, and if you would, tell us how a regulating reservoir actually works.
So, a regulating reservoir works pretty simple and straightforward. When we have fluctuations on our canal system, which any canal system like ours, gravity-fed system that utilizes weirs or other structures to back up the water so that it can flow to surrounding ground for irrigation, these systems have operational fluctuations. They're being manually controlled by farmers and operators in the field, lowering weirs or opening or closing gates. And since we are imperfect in our operations, and also because all of our irrigators don't irrigate exactly the same amount of water for every single field that they own, it creates these small fluctuations in our canal system which build as they travel down. So they add on to or subtract from each other as they move down the system. And the lower system sees the biggest impact from these fluctuations. What a reservoir does in a middle point or close to the end of the system is it takes those fluctuations when they're high. So when you have more water than is being used downstream, it uses sensors to read that increase in water elevation, in this case, in a drop below it, and it opens a gate into the reservoir to direct that flow instead of allowing it to pass downstream and exit our system as spill. It allows it to pass into the reservoir for storage and potential future use of that water, saving that water for the district, and making it so we have to send less down from Turlock Lake and Don Pedro. In times when it's short, when those fluctuations lead to shortages, which occasionally would either delay irrigations downstream or cause the district to turn on groundwater pumps to meet the demands downstream, the reservoir instead will direct water from itself that it has saved back into the canal system to meet those shortages. So it really acts as a reset point for the canal.
Very good. Let's look at lateral 8 specifically then and talk a little bit about how that regulating reservoir functions in its specific location and kind of what affects its operations.
So the lateral 8 reservoir has a more complex interface with its system than the series main reservoir does. The lateral 8 reservoir actually interfaces with several drops upstream of itself rather than the drop immediately next to it. That's because we wanted it to be able to take water off of the highline spill, and we still wanted the reservoir to be located close to lateral 7 and lateral 8, and the highline spill was located some distance upstream. So what the reservoir does is it interfaces with the TCC system on the highline canal in lateral 8 and uses the sensors at drop 14 to monitor the levels at the spill. So that when the water would come up and go into that spillway, it instead sends the water using the automated gates on the canal, sends that water down to the reservoir, so that the reservoir can then capture it. So it sort of interfaces with those drop structures to allow them to send that water down.
Okay. So the spill you're referencing, just for the benefit of our listeners who might not be familiar, would basically otherwise be water that's leaves the system and is lost to us as far as having a useful benefit.
Correct. And the highline gets more fluctuations than many canals do just because it interfaces with a lot of these hillside drains. So any kind of storm water running off into our system, a lot of it comes into the highline, including Mustang Creek. And then we have a lot of irrigators out there who are on micro drip systems. And those systems, kick on and off more frequently than, say, a flood irrigation does.
Got it. Okay. So then this water that would otherwise work its way through the system, we're able to reroute, so to speak, to the regulating reservoir and save it there for future use.
Correct.
Okay. Very cool. All right. Let's do the same then for series main regulating reservoir. Tell us about how it kind of interplays with its surrounding location.
So the series main regulating reservoir is comparatively much more simple. It interfaces directly with the drop next to it, drop 21 on the series main, and watches the levels basically immediately next to it. And when those levels rise, due to a operational increase in flow from upstream, it opens its inlet and allows that water to pass into the reservoir. And then correspondingly, if levels decrease, either because there's been an operational decision to increase flows to a lateral upstream or an extra need downstream, that level will correspondingly drop, and the reservoir will shut off the inlet if it's open, or turn on pumps to divert water from the reservoir back into the canal.
Okay, and you mentioned drop 21. What is the significance of drop 21 to the series main TCC or total channel control system?
So essentially, drop 21 is the new, you could call it a pseudo head of the series main, because drop 21 is the top of the new total channel control system for the series main, for the lower reach of the series main. The series main reservoir project required us to rehabilitate drops 21, 22, and 23 on the series main in order to more consistently control levels for the pond. But it also allowed us the opportunity to automate those 3 drops as that's what we're doing with most of our drop improvement projects at the district these days. And we also had a plan to automate the head of lower lateral 4 and series main drop 25. So it just made it, very, very marginal increase in cost on irrigation capital to tie those new drops together as a total channel control system.
Okay, let's talk about real quick the flow capacities in and out of the reservoir.
So lateral 8 has an outlet capacity of 40 CFS to the lateral 8 canal, and then 20 CFS to the lateral 7 canal. So it has a pumped outlet of capacity of total of 60 CFS if they are all running at the same time.
And how about intake?
And inlet capacity, it has about an 80 CFS inlet capacity on one Rubicon flume gate into the reservoir.
Okay. And what about series main regulating reservoir?
The series main regulating reservoir, because it interfaces with such a larger canal and is a larger facility, it has an intake capacity of 100 CFS and an outlet capacity of 100 CFS done by 4 25 CFS pumps.
Okay, fantastic. Are there other regulating reservoirs that exist outside of the two that TID has in our area or even throughout the state?
Yes, there are other regulating reservoirs, even just around us. Oakdale, South San Joaquin, MID all have regulating reservoirs. One of the big differences for our regulating reservoirs is that the locations that we needed them necessitated lining the bottom. For example, MID's reservoir, they were fortunate enough to find clay hardpan for the bottom, which saved them the need to line the bottom of those reservoirs.
And that was just there naturally where they decided to build their reservoir.
Correct. Yes. They built higher up in the hills, and that's actually pretty consistent for a number of these reservoirs, that they're built much higher up in longer systems. And therefore they can take advantage of those clay bottoms, in order to avoid needing, bottom lining. So we actually did, for both of our reservoirs, we looked at, various different kinds of lining, to use and whether or not we even needed to use, lining if we could, benefit from, say, groundwater recharge, on these projects. But in both cases, we found that the infiltration rate, the rate that water sinks into the soil, was very high, and that high infiltration rate was going to not remain local. It was going to essentially quickly leave the area and likely head towards the local rivers. And also it was going to locally increase the groundwater table. And both of our two regulating reservoirs are immediately adjacent to orchards, which do need the groundwater table to stay below a certain height to avoid impacting those crops. So the decision was made to line, and we looked at various different kinds of lining. We looked at bringing clay down. We looked at soil cement, and we looked at concrete, which was ultimately the decision. It was a surprising decision because concrete is considered to be, in general, one of the more expensive options for lining, but we did a cost comparison for what our crews could install concrete liner for and what contractors were offering to install soil cement for, and we found them to be comparable. And when the prices came in comparable, concrete is just the superior liner, easier to maintain, easier to repair, and it's also higher infiltration resistance. So we save more water in the reservoir with concrete than we would with, say, soil cement.
Okay, fantastic. Boy, there's a lot to consider when putting these regulating reservoirs together.
Yeah, there is.
Okay, I mentioned earlier we were going to come back and talk about total channel control, because both of these regulating reservoirs, both lateral 8 and series main regulating reservoir, have this total channel control system, or TCC as we refer to it. How does the TCC work? So
a regular canal system, gravity fed like ours is, generally checks up water with drop structures. So water flows downhill the same as it does with a river, and it checks up the water to a height that can irrigate the surrounding ground by using weirs and gates to artificially elevate that water. But one of the drawbacks of that kind of a system is that any fluctuations in that system just immediately pour over the weir or go through the gate and pass downstream to the next drop, and then onward and out to the drains. A total channel control system sees those changes, those fluctuations in water level, and automatically makes adjustments. So let's say a farmer in a drop opens his side gate to start his scheduled irrigation. That can sometimes cause a drop in the water level inside of his drop his regulating drop. The system would then see that level of drop and then cause the gates upstream to open to fill that hole. And then it would also communicate with all the gates upstream of that, and those gates would also automatically adjust to maintain those levels. So it sends water downstream when it's needed. Correspondingly, when that irrigator shuts his gate, you may see a small surge in the water level inside of that drop as that water begins to move downstream. The system would correspondingly send a message to the drop upstream to close itself off and prevent that water from spilling. And then it would pass that water onwards and upwards to a storage facility, in this case, the series main regulating reservoir or the lateral 8 regulating reservoir.
Okay. And how in the past, prior to the TCC installation, how would our WDOs or our water distribution operators have compensated themselves for these fluctuations?
So the spills would just be allowed to pass downstream to the drains, but any shortages on the system, they would use groundwater pumps to make up the differences, and that's something that the reservoirs essentially replace, are that groundwater pumping.
Okay, great. So essentially, then the total channel control system is helping us keep that kind of equal levels throughout the entire canal system. Is that fair to say?
It's holding levels much more constant for irrigations and preventing those fluctuations, yes.
Okay, great. What are some of the challenges of a total channel control system?
So one of the challenges of a total channel control system is it is technology. So it can have any of the errors that you can think of from technology, which is, communication losses. It needs to be monitored and maintained by professionals, electronics technicians, and water operators, just to make sure that everything is functioning correctly and properly.
All right. And what about with the first total channel control system that we installed? I imagine that was that was a new thing for the district. Were there any challenges or any discoveries that were made in the installation and implementation of that first system?
Yeah, the total channel control system on lateral 8 was by and large a success. However, we did put it in one of the most difficult locations to have a total channel control system in the district. Lateral 8 is a relatively small canal that still serves flood irrigations, which, correspondingly are large in size. So there are parts of lateral 8 where a single irrigation can be almost half the capacity of the canal. The fact that we were operating the canal at its relative maximum capacity made it very difficult for the total channel control system in many cases to keep up. Because the total channel control system is predicated on small changes to avoid fluctuations. And when you have these very, very large changes in flow, it can take the TCC system some time to catch up. So we ended up having to implement a sort of a relief mode in the total channel control system, which would allow, when there were big fluctuations upward, would allow some of that water to pass by the TCC system and spill out the bottom until the TCC system could catch up and stabilize those levels. And that helped to alleviate some of the issues that we were seeing on there with very high water levels at times of heavy fluctuations.
Okay. Any of these same issues on the series main regulating reservoir? No,
there shouldn't be any of these same issues on the series main regulating reservoir because it's coming off of the series main canal, which correspondingly to lateral 8 is a much larger canal, much bigger pools. And so takeouts of 15 CFS to any of the irrigators is correspondingly a smaller amount when compared to the total. So the fluctuations will not be nearly so drastic.
Got it. Okay. So, Matt, how would you say having these regulating reservoirs has impacted TID's operations?
I think these reservoirs have been a game changer for the district and the areas that they've gone in. At least the operators sing their praises. I think that they've helped to minimize impacts to irrigators on our bottom end. They provided the WDOs a method of providing water when there's shortages. Rather than turning on groundwater pumps. I think they've improved water quality inside the canals. I think they've saved the district a lot of water. They've met or exceeded expectations so far. And we've had glowing reports from many of the customers on the total channel control systems about how much more reliable their water is.
Absolutely. Okay. So, Matt, I know you have 2 little girls. Yes?
I do.
Okay. And I would never ask you to pick a favorite between the 2 of them, but I am going to ask you to pick a favorite regulating reservoir, lateral 8 or series main.
Oof. That's as hard as picking a favorite daughter. I have very fond feelings towards both of the reservoirs that I've designed and overseen construction for. They have their own charms. They each have their own benefits. They each have their own little hurdles to overcome. But I think both of them have been, enormously helpful in their areas, and I look forward to building many more. All
right. And on that note, I know that the district has plans to add a 3rd regulating reservoir at lateral 5.5. What changes do you have in mind for that design when it comes time to put that project together?
Yeah, so I have learned a lot more about placing concrete in hot weather, and I'm pretty determined never to do that again. So there are plans to line lateral 5.5 in the same way, and we're going to look into those plans and maybe work a little bit harder on scheduling, a little bit more consideration for grant timelines and deadlines. And hopefully we can make sure that we pour that concrete out there in a much more beneficial weather.
A little more temperate.
Yeah, a little bit more temperate.
A little bit later in this podcast, I'll be chatting with Chris Hardin, who's the Construction and Maintenance Department Manager. And I have a question for him along the lines of, you built it, now how do you maintain it? So my question for you is, after the regulating reservoirs are built and operational, what's your ongoing responsibility to the project?
So anytime that there's a necessary change in operations at the pond, and sometimes there have been some requests from operators to adjust things or run things a little differently, or anytime there's a need to inspect the facility over the next, 50 plus years of its operation. That'll be conducted by civil engineering, myself or another civil engineer. We'll need to go out there, check the site, look for any damage, look for any repairs, and just answer any questions that the present or new operators might have about the operations of that facility.
Okay, great. Okay, before we let you get out of here, anything else that you want to add with regard to TID's regulating reservoirs that we should know?
Yeah, these reservoirs have been a huge benefit to the district, and I think it's important to note that they've been entirely designed, entirely constructed, essentially by the district. They really are a testament to what the district can accomplish, what the ratepayers' money pays for. They've been very competitively priced. And very, very effective, and they will last for several generations. So this is really, I think, a very prudent and valuable investment that the district has chosen to make.
Fantastic. All right. Well, Matt, thanks so much for joining us today.
It's been my pleasure, Constance. Thank you.
We're now joined by Construction and Maintenance Department Manager Chris Hardin. Chris, you previously joined us on episode 9 of the podcast, which was way back in January 2022. We're glad to have you back. Thanks for being here.
Thank you for having me.
We're especially excited to have you back today to discuss with us the amazing work your team has done to construct both of the district's regulating reservoirs, both lateral 8 and the series main regulating reservoir. But for those of our listeners who maybe haven't heard the podcast before or missed the episode that you were on earlier, would you start by giving us a quick overview of your background with the district?
Yeah, I started with the district back in January of 2007 as a maintenance worker. I worked my way up from there to a heavy equipment operator into the division manager position. After the division manager spot, I went to the construction maintenance department manager position in 2019.
Great. All right. So before we get in and talk about the actual construction of the regulating reservoirs, I want you to tell us about something that I find really unique about TID's approach to doing projects like this that I think a lot of people wouldn't assume happens, and that is that your team bids on TID's own projects. What can you tell me more about that?
Yeah, here at TID, we run our construction maintenance department just like any other outside contractor. When it comes to capital projects like this, we want to make sure we're the right fit for the district. The civil will give us drawings. We'll go through, we'll look at our materials list. We'll look at our labor costs. We'll put everything together. We'll throw a bid out there. Being a not-for-profit company gives us a little bit more flexibility to work around some things. Another one great example of this last winter with the weather we had, you would typically get change orders from a contractor where being in-house, we can absorb these and keep moving forward and go at our timeline. We're not pushing somebody back where they would have been pushed back 2 months. After submitting our bid, we can work with civil to see what is the best decision for the district at the time, whether it be cost or the actual time frame.
Right, because it might be financially beneficial for the district to do it, but then that's going to mean that you're putting your people on that job and potentially taking them off of other project or other maintenance duties that need to be taken care of.
Correct.
Okay. So it's not just the district saying, hey, we've got the staff, let's build it ourselves. But you're going through the full bidding process to make sure that it actually is the best decision for TID.
Yeah, a perfect example of that is the series main reservoir. We didn't feel that the pump station was actually in our wheelhouse, something that we were comfortable with because it's not a project that we had done before. And once the contractor bids came back, we ended up putting a bid together and were ultimately selected. Means that we were a little bit cheaper.
Very good. And we're going to talk a little bit more about the pump station and that whole part of the project in just a little bit. I've got some questions for you on that. What are some of the other considerations that construction and maintenance takes into account when they're bidding for a TID project?
Well, with the canal system being 250 miles long, we always have maintenance going on. Looking a year in advance, sometimes at some of these projects, we may defer maintenance, move things around that are more important that we might need to defer the next year to accommodate this project. Just pretty much make everything fit together.
Yeah, absolutely. So back when Lateral 8 was constructed and construction and maintenance was awarded that job, were you excited or not, given the magnitude of that project?
Yeah, the crew was excited. We hadn't had a project like that since the early 2000s. But we also know that we needed to step things up, such as using technology to speed up the process. We went out and we looked at a roller screed. Not only was this better for our guys, but it gave us a better product and was faster.
Okay, I'm going to need you to describe for our listeners what a roller screed is.
So when doing concrete lining, you're pouring concrete on a hill. You have to go through and you have to screed the concrete down. With the roller screed, it actually is a pipe that works off of hydraulics, and it'll screed the concrete up to give it a perfect flat finish.
Okay. Something that would be very important when you're pouring as much concrete into these reservoirs as you guys have. Okay, so now let's jump into more of the construction process. So both projects were fairly similar. So let's talk about what all went into the construction of kind of the reservoirs in general.
So you got the preparation of the land, dirt removal, earthwork, grading and actually building up of the banks themselves, the pump station, which includes an inlet structure and the outlet as these feed in and out, the concrete lining, sides and floor, and then also the total channel control that we did on Lateral 8 and a few drops on the series main. Okay.
So obviously a lot that goes into it. Let's dive into some of these a little bit more. So you mentioned dirt removal, because obviously we're creating a pond to hold the water in. How much dirt was removed from each site?
So I'm not sure the exact amount that was removed, but I know that we handled over 100,000 yards. So some of that was removed and the other half was actually used in creating the banks themselves.
Oh, okay. Very good. And I'm glad you mentioned that because there was probably some work that had to be done around the series regulating reservoir to kind of shore up some of those banks, given its location kind of tucked in the middle of an agriculture area.
Yeah, we went ahead knowing that we also have future projects going to happen in that area and beefed up the banks. We went to our new district standard, which is 18 foot wide and a flat top, all the way from Faith Home to Moffett and back out to Keys.
Okay, great. All right. Now let's go back to that pump station because there were some unique things that had to go into place to put that in. Tell us about some of the specs that go along with that pump station.
Yeah, this was a tricky project because it's 20 foot tall and 18 inches thick on the walls and also on the floor. And when you go out there, it doesn't look that big because it's in the ground now. But when constructing this project, it all had to be dug out. So everything was done with scaffolding. And as you can imagine, the inlet pipe is 72 inches, which had to be framed into the walls. And that's 12 foot off the ground. And as we finished it up, it has 4 75 horsepower pumps with 4 30-inch discharges and an extra one kicking over to lateral 3 as a kind of a safety fill.
Okay, wow, yeah. And for having never done that before, that must have been a big learning opportunity for your team.
Yeah, and the guys are excited as we're looking into building future reservoirs to not only use what they learned, but to grow from it.
Yeah, definitely. Very cool. Okay, so let's take a look now at some of the unique characteristics of each project. What are some of the characteristics, if you will, that make the series main regulating reservoir unique?
So purely the size of this one, it's double the size of what we did on 8. I believe it's 39 acres and lateral 8 was 22. The early start to the irrigation season due to the weather we had this winter and having to run stormwater. And also that the series main was an orchard when we got there versus lateral 8 was actually kind of a basin already is shaped from the Hillmore County Water District's treatment site.
Okay, very good. And then also with the series main regulating reservoir, there were some bank improvements that needed to happen as part of that project, right?
Yeah, this is for future projects with Project Nexus. This is to accommodate not only the solar along the canal banks themselves, but we also built a pad for the battery storage area within the fenced area on the regulating reservoir.
Yeah, I would imagine that would be a challenge in and of itself, knowing that there is more that's going to be happening around that site and not having to want to go back and redo what you guys have already done. So just being able to kind of think ahead and anticipate the needs of what other projects are going to be out there.
Yeah, and for the efficiency for the district to not have to go back and start a project over.
Yeah, absolutely. Absolutely. Okay, so lateral 8 regulating reservoir also required a number of renovations to the irrigation system surrounding the project. What can you tell us about those?
So on 8, we did a total channel control where we actually did a drop rehab on all 13 drops to be able to read back and forth and utilize the reservoir.
Great. Yeah. And Matt walked us through kind of what that total channel control looks like. But obviously somebody had to put those in place. So thanks to your team for handling that part of the project. Okay. So now let's take a look at kind of the time frame that it took to build each of these projects. You mentioned that series main is considerably larger, but how long did it take to build lateral 8?
We started in December of 2015 and wrapped up by the start of irrigation season, April of 16. The series main reservoir, we got pushed back due to some of our permitting processes, and we started that in October and didn't wrap up till August. Part of that was because of the weather too.
Yeah, you guys definitely did have some weather issues to contend with, considering we had one of the wettest winters on record. Tell me more about what that actually meant to you guys. How did that hold up the project? What sort of delays did that cause?
So with the project, we had standing water due to the excessive amounts of rain that we had to not only pump out, but then would have to peel some of the dirt back that turned into slop to regain our compaction. On top of just the project issues, we had some bank issues out throughout the district that we had to go out and pull up washouts and regrade or maintain access for our WDOs to be able to run winter stormwater.
Right, because it wasn't just the weather impacts to the Ceres Main Regulating Reservoir project itself, but the storms also caused issues throughout the system that you guys had to take care of.
Correct. And there was a lot of work that wasn't able to get done.
Sure, absolutely. So what sort of work could be done then, even with all the weather that was coming through?
Out there, just pumping the water out, continually trying to keep that project going, keeping the canal system up and running with patching canals, pulling up washouts, and anything that we needed to assist WDOs with moving stormwater.
Yeah, there was definitely plenty of stormwater to be moved too. That's for sure. What sort of work couldn't you do, given that it was so wet and you kind of had to put off or haven't yet gotten to?
Due to the limited access to our canal banks, there was a lot of weeds that we couldn't spray, putting down pre-emergent or pulling up washouts. Some of our patch crews had to walk in to be able to get into certain areas just because we couldn't access the banks. And then we also lost some of our winter season due to early irrigation season starting and running stormwater.
Right. Okay. Well, none of these projects, whether we're talking on the maintenance side or we're talking about the larger projects like these regulating reservoirs, none of these could be done without the talented team you have. So tell us a little bit about who all worked on the project.
So in the winter, WDOs come over to the construction and maintenance department. So we have the WDOs, our heavy equipment operators, our welders, maintenance workers, pump department. This consisted of about 60 total individuals on the Ceres Main regulating reservoir versus the 40 that we had working on lateral 8.
Okay, very good. Bigger project, bigger staff. And now were all 60 of these people out there working every day at the project site, or where did all of this work happen?
No, we tried to work in conjunction as much as we could just because it was a big project site. But you may go out there and we may have 10 equipment operators moving dirt. And then as we got later in the project, there was guys forming up for the pump station versus the pouring of the concrete. One thing that we did on 8 was we poured all the lining and then came back and did the floor. With this project being so big and getting so late into the year where we were getting hit with heat, we actually had 2 crews going. We would be pouring lining and floor at the same time.
Jeez. So you got hit with weather on all sides.
Yeah.
Wow. Well, before we move on, I definitely want to give some additional kudos to you and your team, and the skills that they have, and recognize that you guys are just starting a TID Skills Series program where you and your staff are giving hands-on training to those who are interested in a career in the construction field. And I think that's an awesome opportunity to be able to offer our community. So thank you to you and your team for putting that on.
Yeah, thank you. We are excited about the program. We have a lot of volunteers that are wanting to help just give back to the community.
That's great. Very cool. Okay, so moving back to the regulating reservoirs, what were some of the new things that your staff had to learn in order to bring these to fruition?
Tackling the pump structure, we knew we had the confidence to be able to complete this project, and we had the experience. We just had never had a hands-on project this big. One of the issues was framing 20 foot in the air. You know, a lot of our structures are 10 foot tall at the highest. And then a lot of our drops being such smaller drops that we might use rebar half the size and a single mat, where everything on this one was double matted.
What does that mean, double matted?
The wall's so thick, it's 18 inches thick, that we had to have a mat on each side spaced out to make sure we had the structural strength.
So essentially then you kind of have 2 layers of rebar. Is that
correct?
Right? Okay.
And one thing we did this year, you know, we were getting back to doing our bid stuff. We had a vendor actually cut and bend all the rebar ahead of time because it was more cost effective than us doing it in-house on site, especially with the size of the rebar.
Yeah, absolutely. That makes sense. Okay. So you've built them. Now you have to maintain them. What sort of maintenance goes into these regulating reservoirs?
So this is still a learning process. We have 2 different systems here. On the lateral 8, we have a dirt-fed canal. So there's a lot more silt and debris, aquatic growth that's going to happen there. Ceres Main is yet to be seen, but it's concrete lined all the way in and out. We don't think it's going to have near as much maintenance issues, but your typical banks that need to be sprayed, pulled up, washouts, stuff like that.
Yeah, kind of the more routine maintenance stuff that you guys handle regularly.
Yeah, throughout the district.
Okay. Very cool. All right. So looking around at other irrigation districts in the state, would you say it's common for in-house staff to build these types of projects?
Locally, we see a lot more districts hiring it out rather than building inside. I'm sure they're perfectly capable with their crews. I just don't know really crew size or equipment. TID is unique to have a ton of experience from guys that stay at the district. And we have a lot of great equipment that we also utilize to maintain the irrigation system that transfers right over, gives us the ability to do this job.
Absolutely. That makes a lot of sense. And speaking of having the ability in-house, you also coordinated with a number of different departments on the actual design of the reservoir, which was also done in-house. So what other divisions or departments were included on that part of the process?
We've listed a couple, but civil engineering, which also includes survey, water distribution, sending the WDOs over, but also the winter water distribution operators that actually run the winter water and kept water off of our project site. The electrical engineering department that drew up the plans to get power to the pumps, and then the line department for coming out and actually setting poles and getting the power to us. And then Rubicon for coming out and commissioning the gates.
Very cool. So it was a construction and maintenance project, but definitely tapped into a lot of resources around the district to actually make it happen.
Yeah, TID project.
Yeah, very cool. Very cool. All right. Okay, so looking ahead, what's the next big project coming down the line for construction and maintenance?
Right now we have some things moving around, but we're looking at a lot of gunite up on the main canal just for reliability. We also have the automation of the Highline, Drop 1, and the automation of Faith Home Spill.
Okay, so a lot of automation is what I'm hearing.
Yep.
All right, excellent. Well, thank you very much, number one, for contributing your staff's time and energy to building these regulating reservoirs, which are going to be such a huge benefit to the district. And thanks for joining us on the podcast today.
Thank you for having us, and thank you for highlighting the crews on the work they're doing.
Absolutely. Thanks, Chris. Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at TurlockID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.